Here's the first identity we are going to establish. So example 1 says establish the identity that the secant squared of theta minus 1 all over the secant squared of theta is equal to the sine squared of theta. All right, so you are told essentially that this is an identity. This is an equation that is true for every value of theta, okay? When the directions say to establish this identity, you basically need to prove that this statement is true, okay? So what we're going to do, okay, if you kind of read through the tips for establishing an identity, okay, you are going to choose one side of this equation and start working with it, okay, until you get to the other side of the equation, okay? So basically you pick one side of the equation and start working with it. You ignore that other side of the equation, okay? So one of the tips was to start with the more complicated side of the equation, okay? So that is definitely the left side, okay? The reason for that, say you start with the right side, okay, there isn't a ton of stuff you can do with this. Yes, you could turn it into 1 minus cosine squared of theta and go from there, but it is much easier if you start with the complicated side and then try to get the simpler side, okay? So what we're going to do here is we're going to write down the left side, okay? So secant squared theta minus 1 over secant squared theta, okay? And we are going to start manipulating this. We can use identities that we already know, okay? So the ones we just talked about in the last video. We can also use any type of algebraic manipulation that we discussed in example 1, okay? And we're going to, manipulate step by step. It's a process until we get this right side, okay? All right, so here we go. We are trying to achieve sine squared of theta, but again, we're not going to do anything with this sine squared of theta, okay? We're just going to keep working with this left side until we get some kind of equivalent expression, and then eventually it will turn into sine squared of theta, okay? All right, so let's figure out what we can do here. Okay, when I look at what I was given on the left side, I see that the numerator is secant squared of theta minus 1, okay? So immediately in my mind, I think of the Pythagorean identity, okay? One of the Pythagorean identities is that the tangent squared theta plus 1 is equal to secant squared theta, okay? So if you subtract 1 from both sides, we get that tangent squared theta is equal to secant squared theta minus 1, okay? And that is exactly what the numerator is here, okay? So we are going to, in our next step, we are going to write an equivalent expression, okay? Secant squared theta minus 1, that numerator is equivalent to the tangent squared of theta, and then we haven't changed the bottom yet, okay? We only manipulated the top. So I'm going to keep the bottom as secant squared of theta, okay? Now I'm going to move on and try to establish another equivalent expression here, okay? All right, so you want to keep the end goal in mind, okay? So yes, our work will not involve the sine squared of theta, but that's what we're trying to achieve, okay? So the next thing I'm going to try to do is, I've got tangent and secant involved. So both of those things I can turn into sines and cosines, okay? So that is one of the tips that was given when you're establishing an identity. Try turning everything into sines and cosines, okay? All right, the top is tangent squared of theta, okay? I can rewrite that as sine squared theta over cosine squared of theta, okay? That's what tangent squared of theta is. So that's the numerator. And then in the denominator, I have secant squared of theta. That's the same thing as 1 over the cosine squared of theta, okay? And then that is an expression. We've turned it into an equivalent expression, but now it's got sines and cosines, and it actually involves our end goal. We're finally seeing the sine squared of theta appearing, okay? All right, so now at this point, we're just dividing two fractions. So remember how you divide fractions. We're going to leave the top one alone. So I'm going to write down sine squared theta over the cosine squared of theta, okay? We're going to divide by 1 over the cosine squared of theta. So I'm going to change the division to multiplication. I'm going to flip the other fraction, okay? And then that leaves me with this expression. So I'm multiplying two fractions, okay? But at this point, I see a cosine squared theta in the top, one in the bottom, okay? And so they cancel, and this is going to leave me with sine squared theta, okay? And so ultimately, I have achieved the right side, okay? This proves that the secant squared of theta minus 1 all over the secant squared of theta is equal to the sine squared of theta, okay? So we have established or proved or verified, whichever word you want to use, this identity, okay? All right, now, one of the things I mentioned when I was introducing you to establishing identities, okay, there's usually more than one way to do this, okay? So this was just one verification, okay? As long as you can come up with a valid verification, you're good, okay? But maybe this is the method you did. We'll call this, well, actually, let me do it this way. Let me call it verification, okay? So we'll say this is verification number 1. But someone else in your class may have done something different. Okay, so I'm going to show you another way you could have verified this identity. Okay, and as long as you are starting with one side and using valid algebra and your basic identities that we already know, and you're starting with that one side and you're achieving the other side, you're good. Okay, so here's the other way you could have done this. Like I said, there's more than one way to do this, and there's probably even a third way. Okay, I'm still going to start with the complicated side. That doesn't change. Okay, so we've got secant squared theta minus 1 all over secant squared of theta. Okay, we are going to use known identities and algebraic manipulation to try to get sine squared theta on the other side. Okay. Here's the different way you could have approached this, okay? This is a fraction, okay? Let's break up the fraction. The correct way to break up a fraction is to take everything in the numerator and divide by the entire denominator. So I could have done secant squared theta over the entire denominator, kept the minus sign in the middle, put minus 1 over secant squared theta, so take the other term in the top, divide by the entire denominator, okay? And then simplify. Okay, so basically we broke up the fraction in this step. Okay, now we're going to simplify. Okay, this first fraction, secant squared theta divided by secant squared theta, that is just, a quantity divided by itself, so it's going to be 1. And then we're going to subtract 1 over secant squared theta is just basically cosine squared theta. Okay, if you wanted to expound upon this, okay, you can. You could have done, okay, this is 1 over secant squared theta is 1 over the cosine squared of theta. So if you needed to break it up to that degree, that's fine. Okay. And then in your next step, that would be 1 minus 1 over the cosine squared of theta. Remember, that's 1 over 1 times, flip the bottom fraction. That's going to turn into cosine squared of theta. Okay. You could have omitted this step. You could have gone from here to here, but if you need that intermediate step, that is fine, okay? And then you end up with this statement, 1 minus the cosine squared of theta, okay? That's the Pythagorean identity, okay? We know that sine squared theta plus cosine squared theta is equal to 1, and so if we subtract cosine squared theta from both sides, we know that this quantity right here, 1 minus the cosine squared of theta, is equivalent to sine squared of theta, okay? So boom, this gives us the right side of the equation, okay? So we have verified the identity here, okay? This was definitely shorter, okay? They're both correct. We went about both verifications in different ways, but we still started with the most complicated side. We used fundamental identities along the way, algebraic manipulation, and we were able to achieve the right side. Okay, so no matter which way you do it, or even if you come up with a third way, okay? As long as you're following those tactics, those rules for verifying an identity, you're good. Okay, let's try another one.